Welcome to this presentation about blockchain for businesses. So to begin with, I'd like to see what kind of audience we have here today. So how many of you are developers in this audience? That's more than a half. How many of you are familiar with blockchain technology? That's also quite a large number of you. That's pretty good. How many of you have written smart contracts yourself? Not that many. Okay. So you may know that there are several platforms, several platforms out there which you can choose to develop what we call decentralized applications. And I will go a little bit more into what it means with the decentralized applications for those of you who are not too familiar with that. And it's quite important to evaluate these platforms with the use case you have. So all of these platforms are not equal. All of these platforms have their own characteristics, and you want to make sure that you pick the blockchain platform that is best suited for your own use case. And first, a little introduction about myself. So my name is Malcolm Lerider. I work as a senior R&D manager at Neo Blockchain in Shanghai. So the founding team is based in Shanghai. And we have around 30 employees there. And the Neo platform, the blockchain itself, is an open source project. So this means that anyone who is a developer, for example, like you here in the audience, can go to the GitHub, you can see the open issues, you can solve those issues, you can play around with smart contracts, you can, if you find anything that should be improved or fixed, you can open issues yourself as well. So it's a quite exciting project to look at, because now we have between 100 and 200 community developers spread out all over the world and just contributing to the project on their own will because they think it's an interesting technology and they want to be part of building what we call the next generation of our economy. And our development community is also quite special compared to other open source projects. We are more similar to the Linux way of doing open source coding rather than other blockchain platforms. And with that, I mean that we never give any reward or any payments for services on developing on our platform. It is all community initiated. So any developer who wants to do something, they just do it. And then if it turns out to be something that is valuable for the blockchain ecosystem, then a reward is given. So that means that our development community is very, well, developer focused, of course, but also have a lot of very passionate developers. And I will give you a few links later in this presentation so that you can yourself come in contact with the development community and see for yourself. And I work with the R&D team management, so I help to manage the R&D team in Shanghai, and also, of course, the development communities that we have all over the world. And the communities are divided, so there's one big development community, it's called City of Zion, which is English-speaking community. We have a Portuguese-speaking community in Brazil called Neo Research. We have a Chinese-speaking community called NEL, and that's based in China, of course. We have 2 development communities in Japan, and we have small communities also growing up now in Vietnam and Malaysia. So it's very exciting to see how the project is actually starting to gain traction. So what is Neo then? Well, it's a blockchain. I think you got that much. But what makes it different then from other blockchain platforms, and what can you do with it, and so on? Well, Neo is what we call a smart economy. So how many of you here know about Ethereum? That's almost everyone. So Ethereum is a platform where you can build any sort of program. And that program, by being deployed on the Ethereum blockchain, will by nature also be a decentralized blockchain program. That's how you can look at it. And basically anything you can develop on Ethereum, you can also develop on top of Neo. So that's the comparison you can do in terms of what can the platform do. But the similarities end there. So the vision and the mindset of the two platforms are very different. Ethereum wants to build unstoppable applications. And we at Neo Blockchain, we see the technical advantages of having decentralized applications. But we see also that there is a big gap between the two economies we have now. We have, you can call it the real economy that we use, that's all over the world. And then we have the digital token economy. And it's like separate worlds right now. And so what Neo sets out to do is to actually build this platform that is compliant to the regulatory laws that we have all over the world in each jurisdiction. The platform that is compliant and that works together with the current economy to make the current economy more efficient, instead of having what some other platforms want to do to replace the current economy. That's not what Neo sets out to do. So the mindset is very different. And for us, it's built up out of 3 pillars. So it's digital assets. You perhaps know about digital tokens. There's digital identity, which is very specific for the Neo blockchain. So we actually give the option for people or enterprises that uses the blockchain to have a public identity connected to their assets. And smart contracts, of course, where you can actually develop these decentralized applications. So you can look at a smart contract in 2 ways. You can compare it to a regular contract, for those who are not that familiar with smart contracts. If you have a regular contract between 2 parties or more parties, you have certain terms and conditions that are written in that contract and that both parties agree to fulfill. And there are some issues with that, though, because even if you sign the contract, you are not that 100% sure that the other person will actually adhere to the terms and conditions in there. They can choose to not adhere to them on purpose, and they can also forget about certain terms and conditions. It's quite common. And what smart contracts can do is to actually automate this and write these terms and conditions in code so that these terms and conditions are executed accordingly, and there's no single point of failure. So there is no such thing as losing the contract, for example. And the second way to look at smart contract is as a cloud service, basically, where you can, I think you're familiar with Microsoft Azure and Amazon Cloud and so forth. So you can see a blockchain platform with smart contract as cloud service, but without that single point of failure. So for Amazon, for example, then Amazon servers are actually running whatever you deploy there. Whereas on a blockchain platform, a public blockchain platform, it's distributed, so it's decentralized. There is no single point of failure. And in terms of characteristics on why and when you want to use blockchain technology, there are a few characteristics that I think it's important to emphasize a little bit. My background myself is within the software industry. I've been in the SaaS, software as a service, for 5-6 years before I started with blockchain. So the things that make blockchain quite interesting is that all data is, of course, decentralized. So that means that all data is visible. Everybody can see all the information that is on the blockchain. And all data that is stored on the blockchain, for example, the digital assets, everything is traceable. So you can see the history of who sent it to whom. And that's also quite interesting in terms of corruption. We have corruption in many countries, where also in government level. And to see how these funds are actually being used is quite usable. And it's also immutable. So data and assets and history, it can never be deleted. You can never clean the tracks, so to speak, but everything is in there, and you can see the history. So the common use cases on when should I actually use blockchain technology, or when is it useful, it's basically for establishing trust. So any use case where you have a trust issue, that's when the blockchain technology becomes useful. So it can be to establish trust where there is none. And that's, for example, the corruption example, or the monopoly example. If there is a long chain, let's say if you send a parcel from one country to another country, and somewhere along that way that parcel got lost, how do you know where it got lost if the whole chain is a chain of parties that cooperate? So they don't want to make it public on where in the chain that it actually got lost. And using this kind of technology, you can actually make it public where the parcel actually has arrived. So if something gets lost, then you know where in the chain that it got lost. So it's not only for parcels, it's also for supply chain. It's also for medicine and black market. So if something enters the black market and you have a chain of the public history, then you can easily see where in the chain it actually got out from the proper chain. And it can also vastly reduce the cost of trust. And there's many interesting examples, especially whenever there is bureaucracy and where you need manual establishment of trust. So I have a very, very good example. When I live and work in China. And to work in China and get a residence permit in China, I need a document from Sweden that says that I don't have any criminal record. I'm a Swedish citizen. So what I need to do is to get that document from the police department in my local town in Sweden. And then I have to take that to a notary to confirm manually that the person at the police station is actually working there and is the right person. The notarized document needs to be taken to the Ministry of Foreign Affairs in Sweden to manually confirm that the notary is a legal notary. And then that document has to take to the Chinese embassy in Sweden to manually establish that trust that the Ministry of Foreign Affairs is the real Ministry of Foreign Affairs and approved by a correct person. And then that document can be used in China as an official document. So you have many of these use cases where they're all just very slow processes and very expensive processes. Manually confirming this at each step, it doesn't add any value at all to the actual use of that document, but it has to be done like that to establish the trust. So a little bit of background of how we ended up with this blockchain technology. The first use case was actually Bitcoin, which I think all of you know about. So the use case there was to establish a peer-to-peer cash system, or you can see it as currency as well, where there is no single authority that issues this, call it money. And the idea is then that there is no need to have trust, because everybody will know how that currency is created, and it's a very transparent system. And this was built on a consensus algorithm called proof of work. And then a very brilliant man called Vitalik Buterin, he came up with a good way to actually use this algorithm to write Turing-complete smart contracts on the same algorithm. So with Turing-complete smart contract, it means that Turing-complete is basically that you can write any kind of application. Whatever you would like to write, you can actually write it and deploy it on a blockchain foundation. And now we have the third generation with the Neo blockchain, which aims to build this smart economy and uses the DBFT algorithm. And I will give a short introduction to these consensus algorithms so that you know how they are different. So proof of work and proof of stake they are actually a little bit similar. So proof of work means that you need computational power to establish you can see it establish the trust in the network. So anyone can participate in validating transactions, and it is basically a competition between the participants to find the next block. And proof of stake is an attempt to solve the problem of energy waste. So on the Bitcoin network right now, the computational power, the energy that is used for the Bitcoin network is somewhat equal to the energy consumption of the whole Denmark. So it's using a lot of energy, and people see this as a problem. So it's a waste of energy resources that can be used better. So then proof of stake was, you can see, invented. And it tries to mimic the way that proof of work reaches the consensus, but instead of using computational power, it uses tokens in the network. So if you have a lot of tokens in that blockchain, then you have more computational, equal to the computational power in the proof of work. So instead of needing a lot of computational power, you just need a lot of stake in that platform. And these two algorithms end up with a blockchain that looks something like this here. Let's see if I have a pointer. Yes. So when you send a transaction on blockchain, let's say it will be part of one block. So in this example here, you send a transaction. It can be data. It can be sending a digital asset. It will be part of this block here in this example. And then to create this block, there will be a competition in proof of work by energy, in proof of stake by staking the network. And once the next block is found, it will be created and moved to the next one. And what's interesting in these two consensus algorithms is that you get this branching problem. So since there is a competition, there can be several, let's say, proposals or several suggestions on what the next block should be. So how many of you in here have transferred a token in either to one wallet to another or to one exchange to another exchange? Not that many. So when you transfer a token in Bitcoin, Ethereum, or any other proof of work and proof of stake algorithm, what you need to do is you need to wait for confirmations. So usually it's 15 confirmation or 30 confirmations. And why do you need to do that? Well, it's because we have this branching problem. So we have several blocks that can be the next block. And you don't know if your transaction is part of that block or not. So what you have to do with the confirmation is to actually wait. So if you send a transaction here, and for this example, let's say that you need 10 confirmations, then you need to wait until all of these blocks here are created, and you get here, because then you are quite certain that your transaction over here is part of the longest chain. So both proof of work and proof of stake, they follow this longest chain whole algorithm. So always the longest chain is the valid chain. And so this is a quite decent algorithm if you are working with decentralized currencies. So and you don't need these kind of microtransactions. If you're using large value transaction with not that high importance on transaction time, then these are actually quite good algorithms. And proof of work has been proven now since 2008. So it's very secure to use for that use case. However, I'd like to go back to this slide here. We have, for example, Ethereum, which is built for the large-scale decentralized, or no, it's for just unstoppable applications. And the problem we have there is that the use case is not for currencies. So the use case is to try to build these applications on top of an algorithm that is architected to be for a currency. And that's what actually NEO has a different approach. NEO is built from scratch to develop this blockchain that should be used for large-scale decentralized applications. And I'll mention briefly on how the consensus algorithm in NEO works, since it's different from what blockchain, even people in the blockchain industry are not that familiar with the DBFT algorithm. So instead of having a competition between creating the next block, there will be, or there is, a fewer number of validating nodes, and in NEO we call them consensus nodes. So instead, and these consensus nodes are not competing in creating the next block, but one of the consensus nodes will be selected to propose a block, and that's the red one we see up here. So when he proposes a new block, then the other consensus nodes, they will compare all the transactions in that block, see if it aligns with all the transactions that they have received, and if they do agree with that block, they will send a prepare response. And the algorithm is following Byzantine fault tolerance. And computer science people likely know a little bit about how that works. So you need to reach more than 2/3 of the nodes agreeing with that block in order to reach consensus. So if more than 2/3 of the other consensus nodes agree with a block that is being proposed, then we get this situation here. The block is signed and it is created. And if they cannot reach that threshold, if they cannot reach more than 2/3 agreeing with that block, what will happen then is that it will be a changed view. And with changed view, we will jump back here again. So that block will be rejected. It will not be accepted in the blockchain. Instead, one of the other consensus nodes, perhaps D, will be selected to propose his block instead. And then it follows the same here again. See, can we reach more than 2/3 consensus on that block? If yes, sign. If no, then we iterate again to select another block. So it will iterate until 2/3 consensus is reached. And the advantage of this is that we get a chain like this. So we get a chain which does not branch at all, because at any single point of time in the blockchain, there will at most be one block being proposed. And once that block is signed, it's final. So it can never branch and it can never fork. So this is the comparison. So it depends on what use case you have on which consensus algorithm that is actually best for your project. The advantage with the proof of work and proof of stake is availability. So anyone can participate in the network. If the largest mining power would leave the network can still continue. So it will always be available. And the trade-off you have is finality. So what you get is this branching system. And DBFT, instead, it has the advantage of finality. So you have 100% final transactions in each block. And this is, if you have, for example, high volume and high value transactions, it may not be acceptable to have the possibility that it branches and the possibility that you are on the wrong chain. And even if you wait confirmations, you don't reach 100% finality. You reach 99.999% finality, and you have always make this decision if this is acceptable or not. Whereas in the DBFT, you always have 100% finality in every single block. So after it's confirmed, one confirmation, then it's actually completed and cannot be changed. And the trade-off is availability. So we need to reach this 2/3 consensus, or more than 2/3. So if for example, 1/3 of the consensus nodes would have issues, or they would break down for whatever reason, being attacked for whatever reason, then the only thing that would happen then is that you cannot reach this two-third consensus, right? You need more than two-third. So the only thing that happens then is that there will be a block delay. So nothing will happen to the transaction. The transactions are still there. The transactions that you are sending are still put in a mempool, but the next block will not be created until nodes are restored so that more than two-thirds can reach consensus. So if there is, for example, 7 consensus nodes, then if 2 nodes goes down, the network can still continue to produce blocks. If three nodes goes down, then it will stop creating blocks until one of the nodes are restored again. So that's the comparison that you can consider when you choose which platform that is best for you. And one thing that I think is very important as well is programming languages. So when you are developing these decentralized applications, you are doing so by writing what we call smart contracts. And almost all platforms have 1 or 2 languages in which you can write smart contracts. So you have to evaluate which platform you should choose based on smart contract language, and especially if you are a software company who already have development resources. And the reason is, if you don't have the development skills in the platform that you want to use, let's say, for example, that you want to use Ethereum, but you don't have any Solidity developers, you have 2 options. You can either train your developers in Solidity development, which will take time and is very expensive, or you can specifically employ new Solidity developers, which is also very expensive. So then you may, for that reason, decide to pick another platform that is where you actually already have the development resources to start develop directly. So for example, Ethereum is Solidity, EOS is Haskell, and in the Neo blockchain, we actually have all of these languages. So in the Neo blockchain, if you know C#, Python, Java, Golang, or JavaScript, then you can write smart contracts on the Neo blockchain. And how is that possible? Well, we actually have our own virtual machine. So Neo is not a fork of anything. It's built from scratch. So our virtual machine is also built from scratch. And each of these languages have its own compiler to compile that language into the Neo bytecode. So it's not the complete language, so we should be clear on that as well. It's a subset of the language that can be used to write smart contracts, and it can be compiled into what we have an AVM file, which is then deployed on the Neo blockchain. And it's very interesting to see that there's also more languages in development. So for example, the team in Shanghai, we developed C# and we developed the Java compiler. The Python compiler, the Golang compiler, and the JavaScript compiler are all on community initiative. So it's like developers who see that, well, this technology is very interesting, but we have a lot of Python developers, and we want to use Python to write smart contracts. So then they look at how the compilers look like for .NET, or for C# and Java, and they built a Python compiler to support the same. And now actually Python is one of the best supported smart contract languages on the Neo blockchain. So Python and C# are most mature. But you can use any of these languages on Neo. And I also think it's very important on how you intend to monetize on your service or product. And transaction costs play an important role here as well. So you may even want to provide a free service. It may be for some IoT devices where you just want to provide something good for the society. So you want to have it, deploy it, and make it free to use. Or it can be that you actually do want to monetize it somehow. So my background, as I mentioned myself, is within software as a service. So for me, I like the traditional subscription model where you have certain packages, and for each package you get certain functionality. And perhaps you want to monetize it through that traditional way, so not through the blockchain itself, but actually through normal business activities, and also for legal reasons. So you may want to do that just to make it easier for accounting and taxes and so on. Or you do a native token, so you can monetize it through the blockchain tokens as well. But then again, you have these you have to follow the tax ruling, which is different from country to country, and you can also issue a token. And so I think this is very important because all of the platforms now, they basically monetize it through a token system. And it's necessary to do it like that because of how the systems are being built. And they often also issue their own token. But we have to realize that that's not a very feasible way of monetizing it in the way that the current society or use cases are right now. So we haven't reached that stage yet where we have digital tokens as a natural way of doing taxes and accounting. So it's necessary to be able to do this through traditional means. And as long as you have transaction fees in blockchains that have to be paid in a token, you also get the issue from the end user's perspective. So the end user who is actually going to use your service, your product, he has, of course, have to pay to your company, whichever monetizing method that you have chosen. But you also need to pay that transaction fee, and everybody who have used Ethereum know about that. So the end user have to attain this Ether token in order to use the application itself. And that's not easy. First of all, it may not be legal. I live in China. How do a Chinese get a token? It's impossible. It's not legal to run exchanges in China. And then you have, it's not easy from the practical way either, because if you want to attain a token, you need to register at an exchange. You need to enter your bank details, you need to transfer money, you need to buy Bitcoin or Ethereum, you need to transfer that to another exchange because the token you want to buy is not linked to the exchange you can register, and transfer that one to your wallet. It's not something that my mother would be able to do. So I think it's important that we keep transaction fees at zero. So we have to allow for companies to monetize their decentralized application through traditional means and allow the end users to interact with the application for free. So that's also what NEO allows. So the invocations in NEO, an invocation is, you can see it as an interaction with the application. When you send something to the application, or you want to do some computational algorithm on the application, or you want to get information, then you send to the blockchain and you get information back. And this has to be free. And in NEO, we have built it so that if there is a gas fee, that's the token you pay for utility on the NEO blockchain. But if the fee is less than 10 gas, then that invocation will be free, so it doesn't cost anything. So you can actually write this invocation and interact with the blockchain without the end users having to pay anything at all. And instead, on the NEO blockchain, that the fee itself is put on the service provider. So it's relatively expensive to deploy that smart contract on top of the NEO blockchain. But what you get for that in the end is that it's free for the end users to interact with it. So only the company itself has to manage the legalities of gaining that gas token to deploy the smart contract, and the users don't have to worry about that. And I personally think that's very important. I also think it's important to evaluate cross-chain capabilities, Because we will not end up with one public blockchain platform that serves every use case in the whole world. As I mentioned earlier, there are different use cases, and different platforms will be better choice for different use cases. So there is a need for cross-chain interoperability. And there's two cross-chain interoperabilities that are important. One is between completely different chains. For example, communicating between the Ethereum blockchain and the Neo blockchain. That's an important layer that needs to be developed. And so that will always be an off-chain solution in order to do that. And, but in Neo, we also have the Neo X protocol, which is an on-chain, cross-chain solution. So you can see it as, for example, you run a financial use case on the blockchain, and you want to keep that as a permissioned and private chain. You can actually do that with your own Neo chain, so you can host it yourself. And it can also interact with the main chain. And also, so smart contracts can actually invoke each other through these cross-chain mechanisms to use everything on-chain. And the only requirement for that is that the chain is using the Neo virtual machine. So that Neo X protocol is linked to that VM. Which means also that, for example, I try to visualize here on the picture that we have different projects. So Neo is a public blockchain for digital assets. And here is Ontology, which is a blockchain for authorization of data. So we have this data issue. All of you know about the GDPR, for example, where data should not be put on top of the blockchain. So there will always be data that should be stored centrally. And with Ontology project, which is, it's like a sister to Neo. They are also using the Neo virtual machine, and they map data. So they allow databases to still store centralized information, and they map that to identities on the blockchain. So I can, for example, have my information stored at the bank. And through the blockchain, I give authorization to a third party to access, for example, how much money I have on my bank account. And so I think also this also depends on what kind of use case you have. Perhaps you don't have any need for cross-chain interoperability, so then this is not, then you don't need to worry about this. But if you do have the need for cross-chain interoperability, it's important to see if you can actually do that. And you also have to see in what extent can you do that. Can you do it chain to chain, just within that own ecosystem, or can you do it cross-chain to other ecosystems as well? Transaction capabilities is, of course, very important as well. I'm not sure how familiar you are with the discussions in the blockchain industry right now, but it's always talking about the scalability problem. How can we solve the scalability problem? And it is actually an issue when you look at it from proof of work and even proof of stake. So there is a limit on how much you can actually scale it. And there are solutions to that. The most common solutions or biggest solutions that have most support right now is off-chain scaling solutions. So you may have heard about Lightning Network. You may have heard about Lerider. So these are all off-chain scaling capabilities to make it able to transact faster. So what you see here is the on-chain speeds right now. So Bitcoin handles 3 to 5 transactions per second. Ethereum averages around 10 to 20 transactions per second. And Neo does 1,000 transactions per second right now. And the current implementation of Neo can be pushed with improvements to 10,000 transactions per second. But we will likely not do that. We are also developing right now what we call a hyper VM, so a new implementation of our virtual machine, which is built much more modular. It's built in C++ to be faster, and the goal is to have that ready relatively soon and push that to 100,000 transactions per second before 2020. And this is on-chain. So when you think about this scaling solution as well, Lightning Network and Raiden and so on. These are technologies that are not specific to one certain blockchain, but these are generic solutions that you can implement on any blockchain platform. So what you can do is actually implement the same solution on Neo. So you have like the main chain speed is the multiplier of what you can do with off-chain scaling. So a multiplier with 10 to 20 or a multiplier by 100,000 is quite a huge difference in what you can do. And you also have chain of chains with the cross-chain interoperability. So if you can do, for example, right now 1,000 transactions per second on Neo, and you want to be sure that you have that amount of transactions for your own particular use case, you can just host your private net with a private Neo net and use that only for your use case. And then connect it to Neo if you need to. You don't have to. And you can build chain of chains. So with each chain, you basically get the same amount of transaction per second again. And in general, also, I'd like to say a few words about if you want to research blockchain platforms yourself, which I strongly suggest you to do, because I'm not sure I'm completely unbiased when I'm talking about which platform to choose. So I think you should go to, first of all, go to the website, see what the focus is. Because this industry is, it needs more regulation. Not all the platforms are trustworthy. So go to the website and see what their focus is on. If they're focused on technology, or they're focused on marketing, or they're focused on the token. So that's a very good way to get an image of the team and the team culture. Look at the GitHub project to see how many forks and stars it has. Because then you will see how many people are actually have favorized this GitHub to be able to find updates easier, or fork it to be able to deploy their own solutions. So then you have an impression on how many developers are actually using this solution, because you will need developer help sooner or later. So then you of course want people that are already developing on the blockchain that you can ask for help. Check on Twitter content, and this is like the same as the website focus. So on Twitter, having a lot of followers does not equal it is a good platform. You can actually buy followers on Twitter. So it's not a good way to see how much traction a blockchain platform has amongst the community. So you should see on the content there as well. What kind of news are the platforms sending out? What is focus? Is it focused on getting people to buy the token? Or is the focus on technology? Is the focus on developer community? Make that judgment yourself. Check Reddit activity. Reddit is it's like a tool, a communication tool where people ask questions regarding anything regarding the project. So see how active it is. See if there are, how many new posts there are. See how many followers there are, but also see how many online users there are. So online users on Reddit may even be more important than actually subscribers. And check the Discord and Slack activity. How many know what Discord is? How many know what Slack is? That's more, okay. So Discord is almost equal to Slack. It's the same, you use it for the same thing. Discord can handle larger teams than Slack can. So developers will, of course, help each other out, and they will not do that in Telegram, for example. In Telegram, it's not a very good tool to manage development discussions. So then projects use Discord and Slack. So go into their platform and see, are there developers in there that are actually working on development, and what are they talking about, to judge for yourself if the development community is strong or not. Because when you are developing, you want to, you will come across problems. If you're a developer, you will get stuck. And then you want to go somewhere to get help. So then this is where you will go. So check there if there actually is people that can help you out. I don't have too much time. I think you should check on the ecosystem as well. See what kind of projects are already developing on the platform. check the GitHub of the projects that are developing on the blockchain as well, because then you get code examples. It's very difficult to write a smart contract, an application, without having code examples to look at. It's blockchain and smart contract development is relatively new. It's not, you have to think, the programming mindset is quite different from the normal programming mindset, so it's good to have code examples to look at. Watch workshops on YouTube. This is very unbiased also. All the links go to Neo workshops. But you can just YouTube whichever blockchain you're interested in and workshops, and then you will get introduction on how to get started, how to set up the development environment, how to develop your first smart contract, your first decentralized application. And again, a very unbiased slide about how to find the code examples of already developed applications. So these are competitions that have been held on the Neo blockchain. So the winners of these competitions, we have required them to have their code all open source in GitHub. So you can go there and you can see code examples. For example, here, Smart IoT was a winner here. It's an IoT solution on the Neo blockchain, because we have 15-second block time. So you can actually implement IoT solutions on the Neo blockchain as well. And here you have a winner, which is a fighting game on the Neo blockchain. The whole backend is developed in a smart contract. That's also a good example to look at. And if you want to take just one slide on this presentation, then please do it on this slide. So this is how you will get more information about the Neo blockchain. And it's my last slide, and maybe I can take 2 questions. What's it? Yeah, let's take 2 questions. Jeff?
Just a second. Thank you. So we say you have 1,000 transactions per second. Does that mean they are all stored in the main chain? And how that affects the size of the blockchain, and how that affects decentralization?
Right, so yes, it's on the main chain, and it does affect the size of the blockchain. And the advantage is that it's a very good question, because if you have that...
I mean, the key is, doesn't it mean that the blockchain is 100 times bigger than Ethereum?
No. So it's still, it doesn't put 1,000 transactions on the main chains unless there are 1,000 transactions on the main chain. So it will put all the transactions on there. But it is a problem that actually will occur with more transactions. And also, this is very interesting from if you compare the platforms, because Ethereum, anyone can participate. So anyone who is having a validating node have to store the whole chain. And in Neo, we have a fewer amount of validating nodes, which are professionally run. So that enterprises who actually can run professional servers. So for them, it's the size is not really a problem, because for them, storage is very inexpensive. But for example, if I would run it myself personally, then it would be an issue. So I think that's one of the also advantages with the Neo blockchain.
And unfortunately, that's it. We have no more time. So please, if you have any more questions, do it in person. Thank you.
Thank you.